Hi Math 2 Enhanced. This is page 8 of our packet, and I'm going to be looking at the three problems that include the sum or difference of two cubes. So namely number 9, number 11, and then further down number 15. So let's take a look at number 9. When I first look at this, there's a GCF. My GCF is 2. So let's take that out. And once I take out my GCF, what I'm supposed to factor shows up. When I look at this, this is the difference, because it's subtraction, of two cubes. That is a formula. If you remember, we find our cubed roots, and since this is a difference, we're going to subtract them. And then inside my trinomial goes the square, the product, and the square of my two cubed roots. And my signs are the same, so that's the minus sign in my first set of parentheses, opposite, and always positive. So when I try to use that formula here, the cubed root of x cubed is going to give me an x, and the cubed root of 8 is 2. I'm completely ignoring the minus sign. My signs are all in the formula, so I'm not taking a cubed root of negative 8, which is negative 2. I'm only just thinking of the cubed root of x cubed, which is x, and the cubed root of 8, which is 8. And I know since it is the difference of two cubes, I'm going to subtract my two cubed roots, so x minus 2. And in my trinomial is the square, product, and square. So the square of x is x squared. The product of 2 and x is 2x. Completely ignore the minus sign. The signs are in the formula. And the square of 2 is 4. Now my signs are the same. So in my binomial, I have a minus because that's what was in my original, x cubed minus 8. And in my parentheses is the opposite. So now that makes that a plus and always positive. So this is what my x cubed minus 8 factors into. So when I get ready to find my roots, the 2 in front doesn't do anything. There's no variable with it. It doesn't really matter. But the x minus 2 gives me x equals 2. And x squared plus 2x plus 4 equals 0 is not factorable. I need to then use completing the square or quadratic formula. In the solutions, I did it by complete the square. So in this video, I'll do it by quadratic formula, just so you can see it both ways. So my A is 1, my B is 2, and my C is 4. So my quadratic formula is negative B plus or minus B squared, which is 4, minus 4 times A, which is 1, times C, which is 4, all over 2 times A. So it looks like it is negative 2 plus or minus, what is underneath this radical? 4 minus 16, so negative 12, all over 2. So negative 12, I'm thinking about that in my head, and I'm not thinking of 2 times 6. Instead, I think of negative 12 as negative 1 times 4 times 3. So in my head, I'm thinking of this as 4 times 3. I can do the square root of 4. The square root of 4 is 2. I can do the square root of the negative 1. It's I. So this can be simplified to negative 2 plus minus. The square root of 4 is 2. The square root of the negative 1 is I. That leaves a 3 underneath the radical. So now you'll notice that both my terms in the numerator and my denominator all have a factor of 2 I can cancel. So I'm going to end up with negative 1 plus or minus I rad 3 all over 1. This is 2 non-real roots, and this is 1 real root. That gives me a total of 3 roots for my third degree polynomial equation. So let's take a look at number 11. Number 11 has 4 terms. So 4 terms means I'm going to try factor by grouping, and I'm going to see if it works. So when I look at the first 2, it looks like I can take an x cubed out, and I get what? X squared plus 6 minus, looks like I have to take out a negative 1, so I get the same x squared plus 6. So it looks like my parentheses are the same, or x squared plus 6, and my leftovers are x cubed minus 1. So my x cubed minus 1 is not completely factored. So I'm going to factor it. It's the difference of two cubes. So in my head, I'm thinking of the cubed root of x cubed, which is 1. I'm sorry, which is x. I'm getting ahead of myself. And I'm thinking of the cubed root of 1, which is 1. I'm totally ignoring the negative. It's going to be in my formula. That's where my signs are. So x cubed minus 1 factors into a binomial times a trinomial. My binomial is my two cubed roots. That's the red x and the red 1 I kind of scribbled up there. And my trinomial is the square product and square. So the square of x is x squared, the product of 1 times x is x, and the square of 1 is 1. And the signs are the same, opposite, always positive. So that's what my x cubed minus 1 factors into. So now I'm ready to set everything equals 0. X squared plus 6 equals 0. I'm going to subtract 6 from both sides. I'm going to take the square root of both sides. Looks like x is equaling plus or minus the square root of negative 6. Well, the square root of negative 1 is I, and the 6 is just going to stay underneath. That's two non-real roots. X minus 1 equals 0 just gives me x equals 1. And then x squared plus x plus 1 does not factor. So I either need to complete the square or use quadratic formula. So let's use quadratic formula, mainly because my b is 1, which is odd. So I tend not to like to work in fractions with complete the square if I don't have to. So a is 1, b is 1, c is 1. How fun. So my x is equal to negative b plus or minus b squared, which is 1, times 4 times a times c, all over 2 times 1. So then this is negative 1 plus or minus, what is this? The negative square root of 3? Or square root of negative 3, sorry, all over 2. Well, the square root of negative 3, I can pull the negative out and get an I on the outside. So I'm going to write this as negative 1 over a 2, plus minus then I rad 3 over its own 2. When it's imaginary, I don't want to share the denominator, so I want to keep it separate. So this is my two non-real roots. One of them is negative 1/2 plus I rad 3 over 2. The second one is negative 1/2 minus I rad 3 over 2. So that gives me, this is my one real root. So when I add those up, I have 5 roots for my 5th degree polynomial. So let's move on down towards the bottom of our page. Number 15 is another problem where when I look at it, I have a GCF. That GCF is x. And when I take it out, now I can see what I am supposed to do with this problem. I can see that I have the sum of 2 cubes. So I need to continue factoring. And I know the sum of 2 cubes factors into a binomial times a trinomial. I know the binomial is my cubed roots. So the cubed root of x cubed is x, and the cubed root of 27 is 3. So in my binomial is my x and my 3. My trinomial is the square product and square. So x squared, 3 times x, 3 squared is 9. And my signs are the same. So plus sign, different, minus sign, and always positive. So now my zeros, the x gives me x equals 0. X plus 3 gives me x equals negative 3. Those are 2 real roots right there. And then x squared minus 3x plus 9 does not factor. You can create a diamond, put your 9 at the top, negative 3 at the bottom. There's nothing that multiplies to 9 while adding to negative 3. So this is another example of the problem where you have to use complete the square or quadratic formula. I would choose quadratic formula because my b is odd. It's a 3. So my A is 1, my B is -3, and my C is 9. So my x equals negative b, so +3 plus or minus 3 squared, which is 9, minus 4 times 1 times 9, all over 2 times 1. So then this is equal to 3 plus or minus, this is 9 minus 36, which I believe is -27. 9 minus 36, all over 2. Now, -27 is 3 times 9. So in my head, I'm pulling this apart. It's -1 times 3 times 9. Because I can do the square root, x equals 3 over 2 plus minus. I can do the square root of -1, it's an I. I can do the square root of 9, it's a 3. And I'm going to keep my leftover 3 underneath, all over its own 2. Because remember, once I have an I do not want to share my denominator. I have a real part and I have an imaginary part for my complex number, and they don't share the denominator of 2. This is 2 non-real roots. Those are 3/2 plus 3i rad 3 over 2 and 3/2 minus 3i rad 3 over 2. Which gives me a total of 4 total roots for my 4th degree polynomial. I don't think there'd be too many questions on the other problems on this page because they are very much like side 1. But if you do have a question on 10 or 12 or 13 or 14 or 16 that is not answered, please come see me in office hours or ask me during homework time in class, and I would love to go through it with you. Thank you.